Hello, algebra students. So today we're going to get into 7-2, which is solving systems using substitution. So in the last lesson you learned how to solve systems using graphing, which is a very valid method. In most of them you can also graph, but we're going to learn another way to do it, and this way is substitution. There's about 3 different ways that we're going to go over in this section. Graphing, substitution, elimination are the big things that you need to know how to do. So what is the substitution method? Well, the substitution method is replacing one variable with an equivalent expression containing the other variable. And we're going to get into what exactly that means. Alright, we're just going to move on to our first example, so that way I can show you guys exactly what we're doing. Example 1 is just using substitution. So as you can see, I've put a systems of equations here. Y equals negative 4x plus 8 and y equals x plus 7. And we're going to use substitution to solve this equation. And our first step, step 1, is we're going to pick one of these two equations. I'm going to say y equals negative 4x plus 8. Then we're going to take the second equation, and if it wasn't already solved for one variable, we would. But in this case, y is by itself on one side of the equation, so we're good. So we're going to place y in this case with x plus 7. So because this says y equals x plus 7, I can take that and replace this y with it. So now I'm just going to rewrite my equation. Equals negative 4x plus 8. Okay? Because y equals that, I can do that. Now that I've done that, I'm left with only one variable in this equation, x. And so I'm going to solve for x in this case. And I'm going to switch to black because we know it's all one equation now. So I'm going to subtract 7 on this side and subtract 7 on this side. And I'm left with x equals negative 4x plus 1. Now I want to get my x terms on one side. So I'm going to add 4x here and add 4x here. I'm left with 5x equals 1. Okay, but I'm not quite done yet. I still need to solve for x. So I'm going to divide by 5 to get x by itself. I could say x equals 1/5, or if I wanted to make this a decimal, 1 divided by 5 is 0.20. Okay? Either or is correct. Okay? So that's my answer for x in this case. So that was step 1. Step 2 is going to be taking this answer and plugging it back into one of these equations and solving for the variable you don't know yet. So we know what x is. So we could take this equation, and it doesn't matter whichever one you think is simpler. It's more of a judgment call on your point. So I'm going to take this first one just because I think it looks a little bit simpler. So let's do 1/5 and plug it back in here. So y equals 1/5 plus 7. Okay. Now I'm just solving for y. So 1/5 plus 7 is y equals 7 1/5. That's my second answer. Okay. I can write this x, y as a coordinate point. And that's what I should do to show my solution. 1/5 and 7 1/5. That's my final answer. Okay. I could check this by plugging them back into my original 2 equations and seeing if they're correct. Alright, so another example using substitution and the distributive property. I think seeing substitution only done once sometimes isn't enough. I think you need to see it done a couple of times to fully grasp what we're doing. So we're going to start here. And the first thing we're going to do is pick one of these two equations. It really doesn't matter which one. And we're going to solve for either x or y. I'm going to choose this second equation, and I'm going to solve for y, simply because y is already by itself. That's not the case in these other instances. So I'm going to choose this second equation and solve for y. So let's do that first. Negative 6x plus y equals negative 7. Let's add 6x here and add 6x here. I'm left with y equals, we could say negative 7 plus 6x, that's fine. Okay, so now that I have this, y equals negative 7 plus 6x, I'm going to take this answer and plug it into the equation that I didn't use. So I used this first one to find my answer, so now I'm going to plug it into this second one. I'm going to take this answer and plug it in here for y, because it's y equals, right? Let's do that. 3 times negative 7 plus 6x plus 2x equals 4. Okay? You can see I just replaced this y term with this term, which I said was equal down here. Okay? Now that I'm left with just one variable, I can use the methods that I know and solve for that variable. So here, the first thing we're going to do is distribute. 3 times negative 7 is negative 21. 3 times 6 is positive 18x plus 2x equals 4. We can combine like terms. 18x plus 2x gives us 20x equals 4. Okay. Now I want to get my x terms by themselves, so I'm going to add 21 to each side. 20x equals 25. Okay. And now I'm going to divide by 20 on both sides. 25 divided by 20 is 1.25. So x equals 1.25. All right, so I have one of my answers, which is great. Now I need to find y. So now that I know what x is, I can choose either one of these equations, and I can solve for y. Again, I think the second one looks a little bit easier, so that's what I'm going to do. I'm going to erase this work, so if you need to pause the video, please do so. All right, so now let's take this answer and let's plug it into the second one. So negative 6 times 1.25 plus y equals negative 7. So we just plugged this value in here for x. That's all we did, and rewrote this equation. So negative 6 times 1.25 equals negative 7.5 plus y equals negative 7. And we're going to add 7.5 so we can get y by itself. Y equals negative 7 plus 7.5 will give us 0.5. So we have two answers. Now we just need to finish by writing this off as a coordinate pair. Okay. So if I'm going to write this as a coordinate pair, 1.25 comma 0.5. That would be my answer. All right, solve using substitution. So I wanted to give you guys a third example, just because I really want to go over this again. I think substitution can be a little tricky when you first start doing it, and after practice it gets a lot better. So again, we have systems of equations here, and we're going to pick one of these equations, our first step, and solve for one of the variables. It looks like that's already been done for us here. y equals 2x. So there's no sense in trying to solve this one if we already have part of our work done for us. Don't make it more difficult than it needs to be. So because y equals 2x, we can put this 2x here in place of y in this second equation. So let's do that. It's 7x minus 2x equals 15. So I just replaced this y with 2x. Okay. Now that I've done that, I can solve for x. So 7x minus 2x is 5x equals 15. Divide by 5 on both sides. X equals 3. All right, I have one of my answers. Now that I have one of my answers, I can take it and plug it back into one of these two main equations. I'm going to pick this top one just because I think it looks a little bit simpler. I think it'll be a little bit easier to solve. But it really doesn't matter. You could choose the second one if you wanted to, if it looked simpler to you. It's really more of a judgment call, which is something that you'll get better doing with practice. So y equals 2 times the value of x, which I said was 3. So y equals 2 times 3, which is 6. So I have two answers now. My final step, almost done, is I need to write this as a coordinate point. So 3, 6. That's my final answer. And I could check that by taking these two numbers and plugging them back in and seeing if they check out. All right, I hope you come to class prepared to learn about substitution. I hope that you're on track with this information. If you have any questions, please feel free to ask me. And we can work through a couple substitution problems together in class if you need to. All right, thank you guys. Have a good day.